Ladies and gentlemen, boys and girls, my name is Subrata Sarkar. I'm a mechanical engineer working in manufacturing industry since more than 22 years. Today we'll be discussing a special welding process, that is friction welding. Now, before going into the subject, let's have basic understanding of welding. Welding is basically joining two or more metal by application of heat or pressure or only heat. And welding is mostly applicable for the metallic materials, but some of the cases a lot of polymeric material or welding technology is applicable. But we'll be discussing today only on metallic material what welding is applicable. Like welding has a different by types. There are there's a solid state welding, there is a fusion welding, there is a autogeneous welding. A lot of processes there. Even for the this polymeric material, there is a types of the welding. We'll not be discussing that types today in detail. We'll be discussing only one welding process today. Like by types. Now, number one is a gas welding process, then the resistance welding process, arc welding process, and the newer welding like electron beam welding, laser beam welding, and there is a solid states of welding, that is a friction welding, ultrasonic welding, explosive welding, and diffusion welding. These are the special kinds of welding normally you will not find in industry. So today I'll be discussing one of that process, that is the friction welding tool. I'll be discussing today this a special topic, friction welding. Now, before getting into the topic, I would like to share that welding is also one of my most favorite subject. Other than my doing mechanical engineering, I'm also an international welding engineer certified from IW. Also did the BTech section in welding technology through the Jadavpur University in collaboration with IW. So welding is one of my favorite subject, and I always like to share different special welding processes with the people. And also in 2005-06, I used to work in a company in Germany called Welding GmbH. And Welding was basically a manufacturer of metallic bellow expansion joints and a lot of industrial products for welding application is there. But most of the welding is a special welding other than the conventional welding. I learned a lot of about welding from Welding GmbH Germany when I was working there, like laser welding, microplasma welding, there's the ultrasonic welding, submerged welding. These are the special welding I learned from the Germany. So today I'll be sharing one of that areas, that is a friction welding. And those who are a regular viewer of my YouTube channel, you must have seen one of my this topic, that is underwater welding. That is also very interesting welding applications. Now, what is friction actually? If you want to learn the friction welding, friction is force actually. It is opposite to the direction of movement. So you are moving faster, so there is a less friction. You are very difficult to move, so the friction is more. So this is a very basic concepts. So what is friction welding? By application using these mechanical techniques or the physical, friction is basically a subject of physics. So if you arrange your kinematics of the component in such a way that you can generate heat by application of friction, then that can be you can apply that things or frictional heat generation into a welding process actually. Say there is two rods you want to join together, two ends or shafts. So if you fix one shaft in a machine which is a fixed, and another shaft in the same machine coaxially and rotating the shaft and touching both the jobs, and then you start pressure, then there will be heat generation between the faces. You can see here in this picture. So this is basically the concept of the friction welding kinematics, and you will see that there is a flash generated when you do a rotation of the components. One is fixed component, one is the rotating components, and you are putting pressure, axial pressure at the same time, then metallic flashes will be generated. This is a welding flash, and no third metal is not needed. Like in case of MIG welding, you are putting another weld spool actually. So that is not needed. So in that case, uniformity of the joints is much better than the conventional welding processes. And there are very typical application in industry where this friction welding is very popular and successful. And friction welding is also very much integrated with the robotic system. You can see there are a lot of machines where robots are there, and friction welding is equally successful than the other welding processes. And if you would like to know very few simple parameters of the friction welding, you can say the RPM of the shaft, say 1500 RPM, 1000 RPM, like that. The rotating shaft rotates, and this RPM depends on the diameter of the shafts. Ultimately, it is the surface speed of the diameter actually. And if you see the pressure, the axial pressure normally used in friction welding depends on say 6 kg per centimeter square or 12 kg per centimeter square in the normal range of the products used in industry. And there is a called upsetting of the parameters. Say there are the two ends of the shaft are fitted like that, and what would be the axial movement of the jobs actually, which will be flashed. That is a maximum about 6 millimeter, 3 to 6 millimeter, depending on whether it is a solid ends or whether it is a tubular ends. And you can see there the welding process. This is typically the roller of the undercarriage of the excavator, or the track mounted movements, the machines like excavator, tankers, etc., where there is a roller is there on the upper side. There is an idler roller. These rollers are typically joined by this friction welding process. There are a lot of other typical components in industry where friction welding is used actually. Like this is, you can see, this is the ends of a hydraulic cylinder. Hydraulic cylinder used in excavator, construction equipments, mobile cranes, etc., where there is ram of the cylinder. There is a fitment called ram, eye end of the ram with the solid rods, rod end, and this end, these two are joined together by because the process is such that it is not feasible to make both the ends and the body together. So it may manufactured in separate pieces and then joined together. And as this welding has a lot of special quality, and the reliability and joint efficiency is much higher than the conventional MIG welding, so this friction welding is today now very much successful in hydraulic cylinder, eye and welding applications. And you'll find this typical kinematics is like that. The things which needs to be joined together, and that is ends of the welding head, you can say. So some of this kinematics should be such that there is a friction needs to be generated, and at the same time pressure needs to be given, and that will convert it into welding actually. Like big diameter pipe can also be welded with the friction welding process. You can see there is a real picture of the welding. Now, what is the beats of welding? By seeing the components actually, those who are expert, they can say whether this is done by the flash butt welding, or it is done by friction welding, or some other welding process. If the weld bits are kept intact actually, you can see here in this picture, there is you'll find that all these roller of the undercarriage, this type of welding bits are there. This is not a components actually, this is a flash come out from the jobs, and as this is a mechanized, so flashes of the welding come out very uniformly. And for the carbon steel grades, this is very difficult to remove that flash, so it is normally process keep the flash as is actually. And the process for choosing this friction welding for such components actually, this because there's a very good grain flow of the metal. Actually, you can see next here in this picture, the grain flow is such that is automatically joint efficiency get increased actually. And you can check it in the laboratory. These are two pipes or something that is joined by normal welding process and by friction welding process. You'll find a lot of difference in the grain flow actually. And also by say one end of the job is solid and another is a tubular, then only one seam will be formation. So by seam formation of the friction welding, you can say this part is a hollow part, this part is a solid part. It can be seen from here in this picture. Say it is a pipe, this is a solid, so only one bit will be generated. And today, as this spatial welding process is getting popular in many special applications and successful, rather you can say, than the earlier processes. Like this we call it the universal coupling, or call the drive shaft, like that is the eye end. and the pipes are joined together by this friction welding. In automotive industry, for the trucks and buses, the gearboxes, gear shafts are also today. Earlier process was the forging, upsetting forging, make the shafts and do the welding, the machining and fit. But today, to save the raw materials and the manufacturing process, by value addition manufacturing process, you can make the shaft portion and the flange portion different and then joined together by the friction welding, which is ensure much more strength actually. And there is a lot of software that also come today, by you can do before doing the jobs, you can check it the finite element analysis of the welding process of whether this is suitable, applicable, or your specific requirement will be solved or not actually. So there are a lot of advantages of the friction welding. One is the simplicity of the operation, low surface impurities, because during this welding there is a lot of other impurities, possibility of coming is very less, and heat affected zone is very less. That's very interesting. And less shortening of the component actually. They are in comparison to the flashbud welding, and there is no flask is required, like in case of submerged welding, or the gas required, or no filler material is required actually. This is the very uniqueness of the friction welding. But at the same time, there are some limitations of the friction welding. Process is restricted to angular bar joints and flat joints, and in case of the welding process becomes complicated because if geometries are dissimilar, and in case of high carbon steel it's very difficult to remove the flashes. Normally people don't remove in industry, and it requires a very heavy and rigid machine setup actually, because there is a lot of axial pressure during the welding processes. But it has got its own application and requirement in the industry, and day by day is getting popular in many new sector of applications actually. So if you find this presentation is interesting and informative, you can share with your friends, and you can also subscribe my YouTube channels. Thank you very much for your attention and time.